All right, this is a video on how to use dimensional analysis to solve problems. We're going to use it now for conversions between units, but eventually we'll use it for some things called moles later in the year and something called stoichiometry. So I was taught it in high school, thought it was kind of stupid at the time, but I realized as I went on that it was a very easy way to make sure I was getting answers correct. And basically all it does is if you use your labels for dimensional analysis, you're using labels to make sure you multiply and divide the correct way. A simple example, one you probably would not need to use dimensional analysis for, would be something like this. If I say that I weigh 150 pounds, and I ask you how many kilograms that is. Okay, so I'm always going to use a conversion factor. This is some, this is not all of them, but this is a conversion factor. So for example, 1 pound is 16 ounces, or 1 gallon is 4 quarts. Okay, so I'm always going to use these two numbers, the 1 and the 2.2, or the 1 and the 28.35. So I'm either going to multiply or divide by those numbers. And if I use my labels, it will tell me how. So I'm going to multiply by some conversion factor over here. Okay, some conversion factor. I'll move this over here, 350 pounds. So I'm going to multiply by this conversion factor. And obviously I want to know how many kilograms that would be. So 1 kilogram is 2.2 pounds. Now, my labels are going to make sure they cancel. Just like in math, 5 over 5 becomes 1, they cancel out. The 5 and the 5 cancel. Or x divided by x becomes 1 and they cancel. I'm going to make sure, since this is in pounds, my pounds goes in the bottom. So I'm going to put my 2.2 pounds in the bottom, and something equal to that on top. Well, 2.2 pounds is equal to 1 kilogram. This label and this label cancel because they're on top of each other. It's one big fraction. Pounds on top, pounds on bottom, just like 5 over 5, and they cancel. So to convert pounds into kilograms, I divide by 2.2. So if you weren't sure whether you divide or multiply, this will tell you. That's a fairly easy problem. Probably not one you would have to do dimensional analysis on, but if you're ever not sure whether you multiply or divide, look at your labels and make sure they cancel. So I'm going to do 4 quick examples here for you. You can always look back at this video. So whenever you're struggling with dimensional analysis problem, look back at this to see how to do them. First one is to know how many grams are in a gallon of water. So you always start with what they give you. So they're saying you have a gallon. Don't start with grams. That's what we want to finish with. So we're going to finish with grams. So I'm going to start this right here. We have 1 gallon. Okay, and you can do this as one big fraction if you want to, and make some lines. So the line represents multiplying. So I'll keep it as one big fraction. First rule is that's gallons, so I need that label down here. That way I know those labels will cancel because they're on top and bottom of each other. Notice there's nothing right here. There will be at times if we have a fractional label like miles per hour. So we're looking for a conversion. We're trying to get from gallon to grams. So those are volumes. If we look here, we can go gallon to quarts. We can go quart to pints, pint to cups, and there is cup to ounces. And we can probably go ounces to grams at some point in time from there. Ounces to grams over here would be a conversion also. So this only works for water, by the way, because we know how much the mass of an ounce of water is. So I'm going to say here a gallon is 4 quarts. Okay, so 1 gallon is equal to 4 quarts. That label cancel. We're at 4 quarts right now. Again, this label comes down here. Quarts, not the number, just the label. Pick a conversion here. 1 quart is 2 pints. So 1 quart is equal to 2 pints. That label cancel. So if I was getting an answer right now, I would take 4 times 2, which is 8. That means that a gallon is 8 pints. Again, pints right here. Label goes down here. 1 pint is 2 cups, so the 1 goes in the bottom. 1 pint is equal to 2 cups. 2 cups on top. We can go cups to ounces. Again, cup goes in the bottom, so my labels cancel. I don't want to put ounce on the bottom. 1 cup is 8 ounces. So 1 cup is 8 ounces. Right there. So if I would stop right now, I would multiply 1 times 4 times 2 times 2 times 8, divided by all the 1s in the bottom. And you'd get 128 for an answer. That's how many ounces are in 1 gallon. Now we want to get to grams, so we're going to take this conversion 1 ounce is 28.35 grams. So ounce goes in the bottom, 1 ounce, 28.35 grams. Notice the only label I have left that's not canceled is grams, and that's what we were trying to get to. So I know to stop right there. Again, to get an answer, I multiply everything on the bottom, divide by each number on the bottom. Sorry, multiply everything on the top, divide by each number on the bottom. And our answer here is about 3,600. We don't really have a sig figs here, so we'll just say about 3,600. It's actually 3,628 grams. That's how many grams 1 gallon would be in terms of water. Next one. This one, notice, has a fractional label, miles per hour. Okay, so we're going to start with that. We want to finish with centimeters per second. So we're going to go 30 miles per hour. In other words, you're going 30 miles in 1 hour. That's a speed. We want to finish with centimeters per second. So we know we're done when we have centimeters on top, seconds on the bottom. And we can do either one first. I'm going to keep it going as one big thing. Let's go ahead and let's get our miles into centimeters first. So I know miles needs to go down there. Okay, so don't worry about the hour. We're just getting miles into centimeters. And there's not a conversion directly before that, but there is miles to kilometers. We could go kilometers to meters and meters to centimeters. Or we can go miles to feet, feet to inches, and inches to centimeters. Okay, so we'll go this conversion, feet to inches, inches to centimeters. So we can say that 1 mile is 5,280 feet. So 1 mile, 5,280 feet. Miles cancel. So right now we're at feet per hour. Again, label comes down here. From the bottom, 1 foot is 12 inches, so the 1 goes in the bottom. 12 inches on top. That cancels. Again, take our label down here. Inch in the bottom, and 1 inch is 2.54 centimeters. 1 inch, 2.54 centimeters. And maybe you would have known you needed to multiply this by those 3 numbers. If you know that, you can just show me you multiply by those 3 numbers. So I stop right there because I wanted centimeters on top. I've got centimeters on top. I now need to get hours into seconds, and the seconds needs to be on the bottom because it's centimeters per second. So since hours is down here, that label needs to come up top to make those 2 cancel. Okay. Now this conversion's not here. I expect you to know this. We can say that 1 hour is 60 minutes. That cancels with that. We're still not at seconds in the bottom. So minutes in the bottom, minutes comes up top. 1 minute is 60 seconds. That cancels with that. I'm not sure if you can see it all the way over there. I'll move the camera a little bit. 1 minute, 60 seconds. So if we look here, we have our labels. We have centimeters per second. Now listen to me on this and getting the answer, okay? You've done this before, but I'm going to tell you a little bit different way to do this. It'll make it easier for you with your calculator. So type in 30 times 5,280 times 12 times 2.54, and then 1 and 1. You can multiply those if you want to. And then just push divided by, these are all 1s down here, divided by 60, and divide by 60 again. Don't divide by 60 and multiply by 60. Divide and divide. Or you can divide by 3,600. Okay, but I would say just divide by all the numbers on the bottom. When you do that, you get, we technically only have 1 sig fig, so it would be, we're going to round out a little bit differently. We'll say it's about 1,340 centimeters per second. 1,340 centimeters per second is the answer there. I'll do one more example for you, and it's probably the toughest one of the 3. Last one wants to know how many square kilometers are in 4 million square inches. Okay, I won't give you these squared ones or cubed ones real often, but every once in a while, they'll give you one like this. Here's what you got to remember here. We're going to starting with this, we want to finish with square kilometers. So remember, a square kilometer is a big area. A square kilometer is a kilometer on one side and a kilometer on that side. That's 1 square kilometer. A little bit smaller than a square mile, but still a very big area. 4 million square inches is a decent area, but a square inch is only about that big. Okay, and a square kilometer is very big. So it would take a lot of square inches to fit in a square kilometer. So we start with the number we have. We have 4 million square inches. I'm going to write it like this time. You can do it the same way. Okay, you can do it the other way if you want to. We'll ignore the square for right now. We're going to get inches into kilometers. So I'm going to go inches to centimeters. Okay, inches to centimeters. So we know that 1 inch is 2.54 centimeters. Here's the deal though. If I have a box that is 1 inch on each side, that means it is 2.54 centimeters by 2.54 centimeters on each side. So I've got to square this number, the 2.54. You can square it and write that number in there, or sometimes what I do is I just put parentheses around this and say that, okay, 1 inch squared is that squared. But I got to square this number. Don't need to square this one because it's already been squared to make it, but this has got to be squared. So everything after this has to be squared, but this number does not need to be. So inch and inch will cancel. I'm just going to remember to square these numbers. Centimeters is here, so centimeters down here. There is no centimeters to kilometers, but remember you should know to the base unit. So I should be able to go centimeters to the base unit, which would be meters. A meter stick contains 100 centimeters. Again, if I'm going to square it, I got to square the whole quantity. So centimeters, centimeters. But I still have to remember to square this 100. Still not to kilometers squared yet. Again, meters is here. It's the only unit I have left, so it's got to go on the bottom. And we should be able to go from the base unit to kilometers. And a kilometer is 1,000 meters. Again, if I want to square it, I got to square the whole thing. This label cancel. So when you're multiplying this, I got to take 4 million, don't need to square it, times 2.54 squared, or times 2.54 times 2.54. That's a 1, that's a 1, so we can ignore it. Divided by 100 squared, divided by 1,000 squared. So divide, divide. When you do that, you get about 2.58 times 10 to the negative 6th. 2.58 times 10 to the negative 6th kilometers squared. That's way less than 1 kilometer squared because 4 million square inches is actually not that big compared to a square kilometer. I'll put some more dimensional analysis problems on here at some other point in time, but there's some starting ones.